differential equations. In this differential equation, we have two types of differential equations. Differential equation first order, first degree. The second one is differential equations of second order, second and higher order differential equations. Now, first of all, solutions of the first order, first degree differential equations. Next, solutions of the second and higher order differential equations. After that, we have applications of differential equations. Now, these applications are very important, and these are important questions. Anyhow, applications are Newton's law of cooling and orthogonal trajectories, natural growth and decay, and electrical circuits. These four topics are very important. Two questions compulsory from these two topics. If you know how to solve the differential equations, then we can apply that solution for this applications. Now in first order, first degree differential equations, the first topic is exact differential equations. Now, what is the general form of the exact differential equation? First of all, m dx plus n dy equal to 0. Now, this is the general form of the exact differential equation. If you want to say this is exact differential equation, you have to check one condition. The condition is dou m by dou y equal to dou n by dou x. Once again, this condition, dou m by dou y equals to dou n by dou x, means here for m you have to partial differentiate with respect to y. For n you have to partial differentiate with respect to x, means here capital M and capital N are the functions of x and y, means we are doing partial differentiation with respect to x and with respect to y. Finally, dou m by dou y equals to dou n by dou x. If this condition is okay, then m dx plus n dy equal to 0 is called an exact differential equation for this one. If it is an exact differential equation, then the general solution of this differential equation is formula integral m dx plus integral n dy equals to c. C is the constant here. Now, here this is very important. Already I told you, capital M is a function of x and y, and capital N is also function of x and y. But we are integrating with respect to x and we are integrating with respect to y. Means the general solution. Once again, I am taking the formula here. Integral m dx plus integral n dy equals to c. Up to intermediate, we have done. If you are integrating with respect to x, we need the terms only x terms. But here m is a function of x and y, means rule of integration for this exact differential equation. Rule of integration for this differential equation. Once again, the first condition. Treat y terms as constant when integrating with respect to x. Here the first term is integral m dx is available. Means for that purpose, treat y terms as constant when integrating with respect to x. Means wherever if you observe, suppose in the problem if you observe y terms, then you have to write that y terms as outside of the integral. You do the integration for x terms only. Here if you observe y terms, you put those terms as constants. Now second rule. While integrating with respect to y, integrate those terms which are free from x. Once again, while integrating with respect to y, integrate those terms which are free from x. Now, this is nothing but rule of integration while solving calculating the general solution of the exact differential equation. Now, here I will take one small example here. Suppose integral xy dx. Now integral xy dx is there. Now what is the answer for this one? For example, Means what I told, the first condition according to the first rule of integration, integrate those terms, treat y terms as constant when integrating with respect to x. Means y is constant here, you can write y is outside, well integral x dx is nothing but y into x square by 2. Now the same function I will consider. First time I did the integration with respect to x. Now I will do the integration with respect to y. Integral xy dy. Integral xy dy. Now the answer is, it is not free from x. What is that? Once again, second rule of integration, integrate those terms which are free from x. Means when should I integrate with respect to y? If you observe purely by terms, it is free from x, then only I will integrate with respect to y. Otherwise, we will write direct answer is 0. Now, integral xy dy, this is xy is there, it is not free from x. Therefore, the integration of xy dy equal to 0. The answer is 0. Now, this is nothing but exact differential equation. Means, while solving the problem, 3 conditions you have to observe. The first, the equation should be in the form of m dx plus n dy equals to 0. Equal to 0. The second one, condition, exact condition, dou m by dou y equal to dou n by dou x. This is second condition. If the condition is okay, direct formula integral m dx plus integral n dy equal to 0. Means integrate those terms which are free from x while integrating with respect to y. Now, integration with respect to x means treat y terms as constant, means outside of the integration. This is nothing but exact differential equation.